One thing I forgot to say at the end of the last video was this is the exact answer, this is the approximate answer, which is why you use that symbol. Next question. So this one was tangent. Obviously this problem will be sine or cosine. That's just simply how teachers think. So let's see what it is. Here's the angle we're trying to find, and it's very close in size to that one, so our answer should be roughly 20 degrees. Let's see what the protractor says. So stick this on the vertex of the angle, and then make sure the bottom of the protractor is exactly in line with that side of the angle, one side of the angle, and then the other side of the angle. Let's see where it points to. Oh, look at that. It literally is pointing right at 20. So at the end of this process, when I press enter on the calculator, it should say that this angle is about 20 degrees. Alright, here we go. So here's the angle we're trying to find. The side across from it is called the opposite side. The side across from the right angle is called the hypotenuse, and the other side, of course, is the adjacent side. So we are given the opposite side and the hypotenuse, which trig ratio has opposite and hypotenuse in it. Opposite, hypotenuse. So it's a sine. Sine of theta equals opposite over hypotenuse. So let me show you. This time I'm going to say it, but I'm not going to show the work. I'm going to say it, not show it. To me it looks better. So trying to get theta by itself, you take the inverse of both sides. Take the inverse of both sides, that's how you say it. And voila. Oops, off the screen. Doesn't that look so much better than that? And plus, like I said, a lot of students will show it incorrectly. And if you show it incorrectly, I'm going to have to mark it wrong. You know why? Because you're in algebra, specifically advanced algebra, so your algebra skills should be good. So two ways: either show it properly or don't show it at all. Most students prefer this. So, and then you plug that in your calculator. Inverse sine of 3 over 8.5, 20.7 degrees. Remember, I estimated about 20 degrees. The protractor said about 20 degrees, and it's just a little bit over 20 degrees. It's actually closer to 21, but 20 point, let's see, that's 6. We're rounding to 10th place, so you always look at the next place over. If this number is 5 or bigger, that number goes up. Ooh, sorry. Degrees. Angles are always in degrees. Make sure you have a label. And last question. So, this one's tangent, that one's sine. Obviously, this one is a cosine problem, but let's pretend like we don't know that. Here is the angle that we are trying to find. It's big. It's a very big angle. This one is small, less than 20. You could tell by looking at the previous two problems that this one is less than 20. So, but I'm going to call it 20. Let's say that's 20, then this is 70. 20 plus 70 is 90. 90 plus that 90 is 180. All three angles of a triangle must add up to 180 degrees. The protractor says, let's see how close to 70 it is. So you that at the vertex of the angle, and then you just follow the other side of the angle. What am I doing? Oh, right there. That little guy right there. Oh, look at that. Pointing right at 70. Yeah, I guess I probably can do it like this. No, I cannot. So, upside down. 70 is what we should get. Let's pretend like we don't know what's cosine. Here's the angle we are given, or that we're trying to find. Side across from it is the opposite side. The side across from the right angle is the hypotenuse. And the other side must be the adjacent side. Voila. And so we know the adjacent side, we know the hypotenuse. That makes it a cosine problem. So we know the adjacent side, we know the hypotenuse. Cosine. So you write cosine of theta is equal to the adjacent over the hypotenuse, like that. Then you take the inverse of both sides, that will get the theta by itself. And then plug it in your calculator. I'm making the assumption that the answer is approximate. You shouldn't actually do that until you see what the calculator says. Sometimes your answer will not be approximate, it'll be exactly something. Especially next week when we are doing special right triangles, we're going to get exact answers, not approximate answers. Anyway, inverse cosine. 3/11. 74 degrees. My estimate was 70, so that's pretty close. 74.2 degrees. And what would happen if you accidentally have your fraction upside down? Let's see. My guess is it'll say error. Nope, that's not my guess. I know for a fact. And you will learn why when we do something called unit circle, why I can tell without even pressing the button the calculator is going to say error. Whoop, whoop. Domain error. So, that's it. You should be able to do the assignment. Oh. Good luck.